All right, we have to cover today perpendicular lines. All right, so lines, segments, or rays that that form right angles are perpendicular. All right, perpendicular. They intersect at 90 degrees. The symbol. It's an upside down T. Is red perpendicular to. Is perpendicular to. So if we have a vertical line and a horizontal line, with the 90-degree symbol, and the vertical line has points A and D on it. The horizontal line has points B and C on it. We can say that line AD is perpendicular to line BC. Real important, never assume two lines are perpendicular without being told so. Without being told they are. A lot of times in this class, All right, don't write this down. Just watch for a second, okay? There will be two lines that intersect. And maybe this is line L and this is line M. And they appear to be perpendicular just by their look. Agreed? But unless this symbol is here, or you're told that L is perpendicular to M, then that angle is not 90 degrees. It is not 90 degrees unless you're told that it's 90 degrees, or that if you have some sort of proof that it's 90 degrees. Okay? If you're told the angle, those are the only two things right there. All right? Either the symbol or you're told that they're perpendicular. Otherwise, when you look at those two lines, and I ask you, what is this angle measure? You don't know what it is right now, okay? Unless you were to put a protractor on it, and then you could come up with an angle measure. But it's not 90 until you're told that it's 90. All right, so don't ever assume that. So now let me get rid of this if I can. Oh, clicking, I want the eraser. All right, so let's do an example problem. And let's try to get this on your paper. We need right here. And then we're going to try to intersect it right here. Intersecting at point T. And then we're going to come out of T with a ray, but it's not going to bisect this angle. It's going to be more along that line right there. And then we're going to put some more points on this diagram. We're going to go clockwise. So right here, we're going to start with P, going clockwise to Q, to R, W, S. This is 2x. WTR is 5x plus 6. PTQ is 4y minus 2. The question is, find x and y. So that line PR is perpendicular to line SQ. PR perpendicular to SQ. So don't we need to solve for some variables so that this is true? If we want PR, which is, let's go with green, and then SQ, I'm going to color it blue because those are the two lines we're working with here. If I can get my blue highlighter. Here's SQ. We need the value of these variables so that the two lines are perpendicular. Perpendicular means that they intersect at 90 degrees, which means every angle in here, this angle is 90. This angle is also 90, isn't it? All right? So let's do the x first. This 2x angle plus this 5x plus 6 angle, those angles are next to each other, aren't they? They're adjacent angles. So if we add them together, what do they have to equal in order for these lines to be perpendicular? They got to equal 90. Good. So that's how we can solve for x. So if we combine like terms, we get 7x plus 6 equals 90. Subtract 6. So 7x equals 84. Divide by 7. And x equals 12. And then for these lines to be perpendicular, what is this 4y? What does the 4y minus 2 have to be equal to? 4y minus 2 represents this angle formed. This angle formed. See my cursor? It's this angle right here. From there to there. What does the 4y minus 2 have to be equal to? Yeah, here's your clue. It's got to be equal to 90. So we add 2. For y equals 92. And divide both sides by 4. So y equals 93. Any questions on that? Okay, if you don't have any questions on that, then at this time, I'm going to pass out the study guide. And you guys that are at home, your study guide is going to be under the, or it's not going to be, it is under the resources tab.